All right, physicists, let me grab your attention here real quick. We've got a lot to do, and I think that you will want as much time as possible to do your lab, so I need you to listen. I'm going to show you quickly some additions to Canvas. I've got all of your graded lab stuff because I want to talk to you about the rubric and the rubric application, since you will have that for your centripetal acceleration lab as well. I want to make sure that you're setting up your analysis accurately so that you're doing some good physics there. And then I'm going to give you some time to do data collection. That's my plan. My goal is that you will get all of your data collection done today, okay? If you're set and ready to go. That's my hope and my goal. So I'm going to talk as fast as I can without, losing my breath. Just really quickly, I just wanted to draw your attention to a couple of things. We're going to talk a little bit more about it tomorrow, but I know that some of you are looking forward and realizing that, again, Thursday and Friday of this week, we're going to do our final, right, for trimester 2, that kind of practice exam. So I wanted to just show you that I did put the exam format information here. I'll tell you more about it tomorrow, but if you want to look at that, you're welcome to. And then I also found 2 other documents that I thought might be of interest to you. One about the paragraph length response. In particular, it talks about how if you have submitted a response on a free response question that is one of the paragraph length ones, if it's not in complete sentences, then it doesn't get graded. And if it's not in logical flow order, then you can lose points, okay? And I don't mean that as a threat. I just want to let you know, full disclosure, that that's all there. And then there's one here about analysis of uncertainty. Just if you have 5 minutes to take a look at those, just so you can kind of keep them in your brains, that's cool. The other thing I threw on here this morning also was the Chapter 6 Solutions Manual, because I realized that I hadn't put it there. So I apologize for that if you have been waiting for it. It's there. Okay. I want to talk just super briefly about the data collection and processing, and then conclusion evaluation work that you did for the rotational acceleration lab. What I'd like you to do really quickly, you don't need to take your stuff. I want you to just go sit with your group, because I've got your data analysis or the data collection and processing grade, and I just want you to all be able to see it. Does that make sense? So this is that big T of PVC. Why don't you go sit with that person, that group really quickly for me, and I will come around and give you those so fast. Again, I don't want to spend a lot of time, but I also am aware that you do have the opportunity to get more points for these kind of things on this next one, and I want to make sure, my friends over here, we'll get it fixed in a little bit. Is that okay? Just pay attention down. Then you'll get an in for what you need to do, right? Just really quickly. So there are 3 numbers. There's a 210, 210, 210 that says equals something out of 6. Okay, that's what the grade comes from. I graded, as I've told you, all year based on these 3 things. Recording appropriate raw data with units. So as long as I could see that you had some raw data and I could figure out what it was, then you get these points, as long as you have units on it. Okay, that was the big sticking point there. Processing the raw data correctly. I wanted to be able to see somewhere in your sheets document what you did, and so that I could follow it. If I couldn't follow it, then I may have taken a point off there. And then presents process data appropriately. That means in a graph, right? You all know that, with nice labels, okay? And you have some sort of trend line. That's what I'm looking for in those 3 things. Okay, so 2 points for each of those adds up to 6, and your score is out of 6 points. Does that make sense? Sweet. Okay, I'm going to pause for a minute again, and I'm going to, please let me know. Okay, so conclusion evaluation. So this was on the T apparatus with the weights that was spinning really fast, perhaps. Okay, and we did a bunch of analysis. In general, people did okay, but there were a couple of places where I really, really wanted to see stuff, and I only saw it from a couple of people. Mostly, oops, that's not the one I want. I don't want that one. I want conclusion evaluation. Boom, there it is. States a conclusion. A lot of you did that. From our data, we saw that there was an inverse relationship between this and this, or there was a direct relationship between this and this. That's part of it, okay? States a conclusion. Based on a reasonable interpretation of the data, because, the slope went up, or we see that happened. It's this little piece here, that little phrase that says with justification, okay? On lots and lots of people's conclusions, I wrote things like, show me the data, explain the data, document it, tell me how it happened, okay? And some of you even did that, but what I was really hoping to see, and I only saw just a couple of, was for you to then take it the step further. Do you remember we spent 2 days in class trying to figure out the theoretical situation for this? Do you remember that? You had that nasty equation that you got all wiggled out so that you knew what your slope should be, right? So what I really, really wanted to see, and what I really, really want to see on this next lab that you're going to do for me today, is for you to take that theoretical slope, that thing, that value that you think it should be, and compare that to what you got. And even better, the sprinkles and the icing on the top would be then if you figure out what the percent difference is. Are you with me there? Okay. That's what I really, really want to see. Okay. In evaluating procedures, evaluates weaknesses and limitations. This part here, a lot of people, and I didn't see this very much, but I saw it enough that I want to mention it. Often people just want to blame either the equipment. The equipment was bad. If you gave us better equipment, then we could do the better lab. I mean, isn't that always true? Right? The physicists at CERN that are smashing protons with other protons, they could complain about that too. But friends, they've got pretty good equipment, right? But you could also talk about it in terms of what could we have done better? And not, if we just didn't have people involved, right? If we automate the whole thing, sure, if you automate the whole thing, but that's, again, you can get really good data with high school, sophomores, juniors, and seniors taking data, okay? With a stopwatch, you can get good data doing that. And if you know how close you got, then this is a much easier thing to answer, okay? And then finally, suggesting realistic improvements. That's where thinking about things that are, again, things that we could reasonably do in a high school physics classroom, okay? When I was looking through these, I had a couple of examples that I wanted to show you. I'm just going to throw one of these up from one of your classmates here. You don't have to read the whole thing. This is, and when I was putting this up, I'm like, I don't want people to think they need to write paragraphs and paragraphs and paragraphs for a conclusion evaluation. But the thing that made my heart really happy when I read this was this paragraph right here. Because right here in this paragraph, let me highlight it so you can kind of see it better. We'll make it like that. The difference between our experimental and theoretical values was 21 or 25% after we took out some outlying stuff, right? We had to do some thinking. We weren't just spitting it out, okay? We collected this data and it didn't quite work, but it's okay. We figured out that if we took that other data out, that we got a really close experimental slope to the one that we expected, okay? I'm showing you this not because it's perfect, because it's not perfect. In my career, I've almost never seen a perfect lab write-up, okay? But it's got that piece in there, and that's what I really want to show you, okay? Does that make sense? It's all about progress, and it's all about learning, so that's what I want you to focus on today, okay? Questions on that? Because you're going to have an opportunity to do something like this for your next lab that you're doing today, okay? What I'd like you to do right now is to get into your centripetal acceleration lab groups. If you were not here yesterday, then find those that also were not here yesterday. And why don't you make a table right over there so that you can find out what's going to happen here. So just really quickly, I wanted to talk to you about the design since I got it graded, but I want you to move on and start doing stuff in just a minute, but not quite yet, because I just wanted to make sure that you're feeling good about this, okay? So you're defining the problem and selecting variables. It does not have to be long and drawn out, right? Our research question is bleh. Our independent variable is bleh, and our dependent variable is bleh. It can be that simple, okay? Tell me how you're going to control the variables that stay constant. Be specific. We're going to use the same mass, blah, blah, blah. Just say it. You don't have to beat around the bush. Just say it. Make it true. Okay? And then develop a method for the collection of the data. And in this thing right here where it says sufficient relevant data, and this is something that AP really likes, make sure that you're explicit. You want to take multiple trials, right? Yeah, for sure you do. For sure you do. Okay. Is that making sense? All right. Let's look back really quickly. And so my friends that weren't here, I'm gonna kind of, we're doing this in a reverse order a little bit. So just stick with me for a second and then I will hook you up with all of the information. So for my friends that are jumping in to do data, before you do data today, I want to know what you're gonna graph on the X and Y axis. And I want to know what the slope is going to represent in your linear graph. Do you understand what I'm saying here? Do you see where this is going? It's kind of like the other one, but I'm giving you an opportunity to do it and do it really well. Okay? So day 2, and this is up on Canvas as well. I didn't print them because I felt like it was just another piece of paper that you would have for a day and then throw away or recycle, hopefully. Okay? Day 2, determine how to graph the data that you're going to get a linear graph. What will the slope represent? Because you're going to put that in your conclusion evaluation section, right? Okay. Then finish your data analysis and conclusion. For the submission for this lab, due Monday, April Fool's Day, but not joking, it actually is going to be due then, okay? A handwritten graph, one per person. Every person is going to do a handwritten graph. So we're not going to do Excel, or not Excel, but Google Sheets. I only need one data table per group, though. You don't have to recopy. Like, that seems like a lot of silly work, okay? But one handwritten graph per person, okay? And then a conclusion evaluation section that you're going to submit on Canvas, just like we did with the design, because that seemed really easy, and then you don't have to remember to share it with me, right? Because it'll just be there, okay? And that'll be due on Monday, so you got a little time to finish that up. Does that sound okay? So make a plan. Make sure you know what you're going to graph first. Once you have a plan, put goggles on, right? Goggles on first, then get your stuff. Start doing your thing. If you have questions, let me know. Sound good? Sweet. All right. You may begin. Yeah, I'm going to go, yeah.